In today's video, I want to look at solving right triangles. So we're going to look at different types of problems that you may come across. Some of them involve where you are given two sides of the triangle. You have to solve for the third side as well as the angles in the triangle. Then you will be given some problems where it's one side and one angle that is given, and again you have to solve for all sides and all angles. And finally, we will look at some word problems. So first of all, when we say solving a right triangle, that means we need to solve for all sides and all angles. So whenever they say solve a triangle, that just means we want to find all sides and all angles. Just so that you know whenever you get one of these problems exactly what it is actually asking. So when it says solve a triangle, you need to find everything about that right triangle. All three sides, all three angles. Okay. So the first thing that I want to look at is solving a triangle where you are given two sides. So I'll give you an example here. In this example, we've got this right triangle. The right angle is down here. This side's going to be 9, this side's going to be 15. My recommendation to you would be label the other two sides whatever you want. I'll label them alpha and beta just so that you know when you are solving for the other side which side you're actually solving for. It just makes it go more smoothly. Okay. So you're given two sides. Okay. We need to solve for the third side. That's the easiest thing to do. Whenever you're given one of these examples where you're given two sides, easiest thing to first do is solve for the side that you don't yet know. Okay. Just as a notation thing, what we tend to do is we label angles as Greek letters, alpha, beta, gamma if you need the third angle. The side that is opposite that is going to be labelled with the English letter that's associated with that. So opposite alpha, we're going to have A, opposite beta, we'll have B, and if you had the third angle, gamma, which would technically be the right angle in this case, you would have C that's opposite that. Okay, so opposite alpha, I'm going to have side A. A is easy to find using Pythagoras, so you're just going to do 9 squared plus A squared is equal to 15 squared. That gives me A squared would be 225 minus 81, which would be 144, which means that A is equal to 12. We're only dealing with positives here because we are looking at lengths. Okay. So that tells me that A is equal to 12. Now I've got to find alpha and beta. We do this using, you can use sine or cosine. I'll use sine here. You're going to be using our SOHCAHTOA rule here. So like I said, you can use, once you've got all three sides, you can use any of these. I'll use sine. So to find alpha, we know that sine of alpha is equal to opposite divided by the hypotenuse, which is 12 over 15. Then if you go to your calculator, there should be a sine inverse button on it. Sometimes you'll find it above sine, sometimes it's its own separate button, but you will find sine inverse. You may have to do like shift and sine and it will give you sine inverse. You will do sine inverse of 12 over 15. So you are inverting sine here. Like when we looked at our inverse functions for sine, cosine and tangent, that's exactly what you are doing here to find alpha. Okay, we're going to do sine inverse of both sides, and that will give you the angle that is in that first quadrant. Okay, all of these are going to be an angle in quadrant 1 because we know that all angles in a triangle have to add up to 180. You've already got a 90-degree triangle, so you know that the other two angles have to add up to 90 degrees. Okay, so you know that those angles are in quadrant 1 of our unit circle, and that's exactly what sine inverse is going to give you. It's going to give you that angle that's in quadrant 1. So when we do sine inverse of 12 over 15, you get that alpha is equal to 53.13 degrees. I would recommend doing this to 1 or 2 decimal places. You won't have to go further than that. What I'm going to do here to find beta, there's a couple things you can do. You can use sine, cosine, or tan of any of the sides in order to find beta. Again, I'm going to do sine of beta, which is going to be the opposite side being 9 divided by the hypotenuse 15. And then I'm going to do sine inverse of 9 over 15, which will give me 36.87 degrees. Okay. That's what I do, just because the other way that you could have done this is just done, you know that you've got the 90-degree angle already. If I do 180 minus that 90-degree angle, like I said before, I know that the other two angles, alpha and beta, have to add up to 90 degrees. So I know for all of these problems that alpha and beta add to 90. So I could have done 90 degrees minus what I found for alpha in order to find beta. I tend to find beta another way and then use it as a check that both of those angles add to 90. Okay? Like I said, it's up to you which way you want to do this, but that is what I do. I find it's a good check at the end just to add all of my angles together, make sure that those two angles add to 90, which added to that right angle is going to give me 180 degrees. So it's up to you whether you use trig to find that third angle or if you do 90 minus the angle you just found. The next type of example that I want to look at is where you are given one angle and one side. Now this will be one angle that isn't the right angle. The right angle you will know. It is another angle that isn't the right angle. So technically you have two angles in your triangle plus a side. Okay. So for this example, I'm going to use this right triangle. Well, we've got a right angle here, and I know that the hypotenuse of this triangle is 21. And I'm going to know that this angle down here is 42 degrees. I don't know this angle yet. I'm going to call it alpha. The angle, the side opposite it, I will call A, and then I will call this side B. Okay. Easiest thing to find first is going to be alpha. Okay, we'll find alpha first, and then we can go ahead and figure out the other two sides. So like I said, all the angles have to add to 180. And in particular, those two other angles, alpha and 42, have to add to 90 because we already have a 90-degree angle. So I know that 42 plus alpha must equal 90. And then, like I said, plus the other 90-degree angle would give me 180 degrees, which would be the entire triangle. So that tells me that alpha is 48 degrees. Now I have to find A and B. Okay. I'll start out with finding A. Again, using SOHCAHTOA, I know that sine of alpha is equal to the side that's opposite it divided by the hypotenuse. The side that is opposite alpha is A, and the hypotenuse is 21. Now, alpha we just found is 48 degrees. So that tells me that A is going to equal 21 multiplied by sine of 48 degrees, which if you type that into your calculator should come out to 15.61. Again, I would do this to 1 or 2 decimal places. Then we need to find B, okay? Again, you could go ahead and use Pythagoras at this point, okay? I'd say that the value of A, 15.61 squared, plus B squared equals 21 squared, and go ahead and find B that way. But I like to use Pythagoras as a check in this case and use one of my other trig functions in order to find b and then check it using Pythagoras. Okay. So what I'm going to do now is to do sine of 42 degrees is going to equal the side that's opposite it, b, divided by the hypotenuse, which tells me that b is equal to 21 sine 42 degrees, which is equal to 14.05 when you type it into your calculator. Now what I would do to double check is to do a squared, so 15.61 squared, plus b squared, 14.05 squared, is equal to 21 squared. So I would use Pythagoras as my check at the end. So like I said, you can use Pythagoras to find that third side. That is completely fine. I just use trig and then I go back and use Pythagoras at the end as a check. Exactly like I did in the previous problem where I used trig and then I used the fact that all the angles have to add up to 180 degrees in order to check my work. So these are the two different types of problems that you could be given. You can be given a problem where you have two of the sides and you know that one of the angles is a right angle. You have to solve for the other two angles and the other side. So we go ahead and find the side first, then we can find the angles using trig. In this case, you are given one of the sides and then you know one of the angles is a right angle plus one other angle. You can go ahead and find the third angle immediately, and then we're going to solve for the other two sides using trig. We check using Pythagoras. So it's going to follow this same pattern for each one of the problems that you could get. You can use sine, cosine, or tan for any of these, like I've said. I just tend to use sine if I have that information. If not, if you have like an adjacent and a hypotenuse, go ahead and use cosine. It is totally up to you. Okay, I've just used sine in these because of the information I had. But you can use sine, cosine, or tan in order to solve these. Okay. I want to look at a word problem, which is literally just what we've been looking at, but now it's applying it to a real world problem and you have to solve using what we've just done. Okay. So in this word problem, I've got a camera is mounted on a 10-foot pole. Okay. And I want to know what is the angle of depression call it theta d, if the camera needs to capture something that is 10 feet away. Whenever you get one of these word problems, the first thing I want you to do is to draw a picture. So we have a 10-foot pole, okay, and I know that I'm trying to capture something that's 14 feet away. So I've got a 10-foot pole here, and the thing that I'm trying to capture is 14 feet away. Okay. Now let's say that the camera is up here, it's trying to capture something that is down here. Okay. Because we know that there is an angle of depression. Okay, so I know that I'm trying to capture something that is below my line of sight. So if I dot this out, the angle that I am trying to find is this angle here, theta d. Again, we know that it's got to be a downward angle because it's an angle of depression. Okay, so I've got a 10-foot pole. It's trying to capture something effectively that's on the floor 14 feet away. So I don't at the moment know what that hypotenuse is. I know I've got a right triangle here, and I know using my knowledge of angles that this angle here is also theta d. Okay. Reason being, just if you're not familiar with a lot of this stuff with angles, if I go ahead and square this off, this is also a right angle. Okay. I know that this part here would also be a right angle. So these two angles would have to add to 90 degrees. I'll call this angle alpha. Okay. They would have to add to 90 degrees. Well, I know I've got a theta d up here, which tells me that this angle here is also alpha. Okay. Which tells me that that angle in this triangle here must be theta d. Okay. So that's just a quick lesson as to why that would be the case. Okay. Okay. So I know that I'm trying to find theta d. At the moment, I've got two sides of my triangle. I know I can find that third side using Pythagoras. So that's the first thing I'm going to do. So I've got 10 squared plus 14 squared. We'll call it c, is going to equal c squared. So if you go ahead and add those together, I'm going to get 100 plus 196 is equal to c squared. So c is going to be the square root of 296. I need theta d. Now there's a couple ways that you could do this. You could have actually done this without even finding that side c. Okay, we don't need to solve for all angles in this triangle. I just need to know what theta d is. Okay, if you wanted to use sine, okay, sine of theta d would equal the opposite divided by the hypotenuse, so 10 over the square root of 296. If I didn't do that extra step of finding that side, I could have still found theta d by using tan. Tan of theta d, okay, remember from SOHCAHTOA, tan of an angle is opposite divided by adjacent, which is 10 over 14. So now I can do tan inverse of 10 over 14, and that would give me that theta d is equal to 35.54 degrees. Okay. You would have got the same thing if you did sine inverse of 10 over the square root of 296. It's totally up to you which way you wanted to do this. Okay. But because we're used to now with our previous problems of solving for all sides, if we're given two of the sides, you can solve for that third side just so that you have it, and then you have your pick of either sine, cosine or tan in order to solve for theta d. That's totally up to you. So if we had that extra side, then we can go ahead and use sine or cosine. If we didn't do that extra step at the start, then I would have to use tan of theta d is equal to 10 over 14. Okay. You could solve for that other angle if you want, but that's not part of the problem, so we don't need to do that. Here they just wanted what that angle theta d was. So my advice to you here with these problems, before you do anything else, is go ahead and draw it. Figure out what they're asking. And from there on out, you can figure out, okay, do I need another side? Am I looking for an angle? What exactly am I looking for? What's the easiest way to conduct this problem? If you like using sine and cosine, go ahead and find the third side. If you are fine using tan, absolutely go ahead and just do tan inverse of 10 over 14. It's totally up to you. They will all give you the same answer.